students. Today let me discuss about the types of electrodes of electrochemistry. During the last class we discussed about the construction of electrochemical cell, the cell potential and calculation of cell potential or electromotive force from the Nernst equation. The next class is about the types of electrodes. Okay, so based on the chemical reaction, in a half cell, the electrodes are broadly classified into four categories. Okay, they are: first one is a metal ion electrode. Metal ion electrode, and the second one is a metal insoluble salt ion electrode. The third one is a gas electrode, and the fourth one is a redox electrode. All these electrodes are classified based on the chemical reaction on a half cell. Okay, so here the metal is completely soluble in metal ion, and here the insoluble salt or the sparingly soluble metal salt is taken, and here the gases are involved in the reaction, and here the oxidation and reduction is taking place. The example of metal ion electrode is a zinc in zinc sulfate solution or zinc sulfate electrolyte, or another example is a copper in copper sulfate solution. These are the examples of metal and metal ion solution. Here the zinc is present in zinc plus 2 ion solution. And the examples of metal insoluble salt electrode is: one is a calomel electrode, and the second example is a silver chloride electrode. Okay. The next one is the examples of gas electrode is: here the example one is a hydrogen electrode. It is also called as a standard hydrogen electrode. And the next one is a chlorine electrode. Further, next one is a redox electrode. It is also called as a oxidation reduction electrode. Where the single metal atom is involved in the oxidation as well as in the reduction. Nothing but where the metal ion exists in the oxidized as well as reduced state. Okay, let's discuss about the metal ion electrode. Metal ion electrode. Here the example, let's take zinc in zinc sulfate solution. Zinc in zinc sulfate solution or electrolyte. The metal ion electrode is constructed by dipping the zinc electrode in zinc sulfate solution. So here it is a zinc sulfate solution, and this is a electrode zinc, the zinc metal, and this one is a zinc sulfate solution, and this half cell is connected to the another half cell. So what are the half cell reactions occurred in metal ion electrode? The half cell reactions are: of cell reactions are. The zinc in zinc sulfate is not complete electrochemical cell. We are discussing about the only one particular electrode, that is the one half cell, where the zinc metal is dipped in a zinc sulfate solution. Let's discuss what type of chemical reactions are occurred. Nothing but half cell reaction. If the zinc is undergo oxidation, then what happen? The zinc is lose the 2 electrons and converted into zinc plus 2. What is the cell representation here? The zinc plus 2, zinc by zinc plus 2. If the zinc is involved in, or zinc is undergo reduction, okay, where the zinc plus 2 gains the 2 electron and converted into zinc metal. Loss of electron is the oxidation, the gaining of electron is a reduction. Here the cell representation is metal ion by metal, okay, and here the cell potential can be calculated as the E cell is equal to E naught cell minus 2.303 RT by NF log concentration of metal ion by concentration of metal. Here the overall cell reaction is zinc is converted into zinc plus 2. So here concentration of metal by concentration of metal ion. Generally we can consider only the reduction reaction because we can calculate the reduction potential. So E cell is equal to E naught cell minus 2.303 into RT by NF log zinc by zinc plus 2 from this reaction, log concentration of product by concentration of reactant. Generally the concentration of metal is equal to 1, then the equation is E cell is equal to E naught cell minus 2.303 RT. Here N is the number of electrons involved in the redox reaction is a 2, and F log 1 by concentration of zinc plus 2. It is about the metal ion electrode. Metal insoluble salt ion electrode, the second category of electrode, where the two types of electrolyte solutions are taken. One electrolyte solution is sparingly salt solution and another one is a soluble salt solution. For example, the calomel electrode. Mercurous chloride Hg2Cl2 is a mercurous chloride. Commercially it is called as a calomel. And here where the mercury is contact with the mercurous chloride and KCl solution. The mercurous chloride is a sparingly soluble salt solution and KCl is a soluble salt solution. And this sparingly soluble salt and this soluble salt having an anion common, where here the Cl minus and Cl minus anion is common in both type of salt solution. So the metal insoluble salt ion electrode can be defined as the metal is in contact with one of its sparingly soluble salt and a solution of soluble salt having an anion common with the sparingly soluble salt. So in the metal ion insoluble salt ion electrode solution, the metal is contact with the sparingly soluble salt, that is the mercurous chloride, again which is contact with the solution of soluble salt and one common anion Cl and Cl. This is about the metal insoluble salt ion electrode. Then coming to the construction of calomel electrode. The calomel electrode is also used as a secondary reference electrode. The standard hydrogen electrode is used as a primary reference electrode, and calomel electrode is also used as a secondary reference electrode to calculate the electrode potential of another half cell. Coming to the construction of calomel electrode. In this calomel electrode, a glass tube where the platinum wire is dipped into it. The platinum wire is dipped into the glass tube and the mercury is placed at the bottom. Then after, the paste of mercury and mercurous chloride Hg2Cl2, which is also called as a calomel, is also placed after the mercury. The rest of the tube is filled with the KCl solution, and this tube is used to fill the KCl solution, and this complete half cell is connected with another half cell by using salt bridge. This is the salt bridge, and the platinum wire is used to maintain the electrical contact. This is about the construction of calomel electrode. A glass tube which is containing the platinum wire, the mercury, then after paste of mercury and mercurous chloride, and KCl solutions are present in this glass tube, and the salt bridge is connected to the another half cell. Then let me discuss what type of cell reactions are occurred in the calomel electrode. Half cell reactions. Half cell reactions. For example, if this calomel electrode is acting as a cathode. If this calomel electrode is acting as a cathode, the reduction reaction is taking place. So in this reduction reaction, the Hg2Cl2, the mercurous chloride, first divided into Hg2 plus 2 plus 2Cl minus ions. And here this Hg2 plus 2 gains the 2 electron and converted into 2 Hg. Hg2 plus 2 gain the 2 electron, nothing but involved in the reduction and converted into Hg. The net cell reaction is here Hg2 Hg plus 2, then Hg2Cl2 gives rise to 2Hg plus Cl minus ion. The cell representation is in the cell representation, first we have to write the ion, then after the metal. So here the Cl minus ion of aqueous by Hg2Cl2 solid and Hg. If the same calomel electrode is acting as a anode where the oxidation reaction is taking place. If the calomel electrode is connected to the another half cell, depending upon the nature of another half cell and depending upon the electrode potential of two half cells, the calomel may be involved in the reduction or the calomel electrode may be involved in the oxidation. If it is acting as a cathode, the reduction reaction is taking place. So where the mercurous chloride is first divided into Hg2 plus 2 plus 2Cl minus, and this Hg2 plus 2 gain the 2 electrons and converted into Hg. The net cell reaction is this one, and the cell is represented as, in case of cathode, first ion, then after metal. For example, if it is involved in the oxidation, what happened here? This 2Hg lost the 2 electrons and converted into Hg2 plus 2. This Hg2 plus 2 take this 2 Cl minus ion and again it is reversely converted into Hg2 Cl2. The cell potential of this calomel electrode is calculated as a E cell is equal to E naught cell minus 2.303 RT by NF log concentration of ion by concentration of metal So here the concentration of ion Cl minus ion, two Cl minus ions are there. So here the N is the number of electrons. Or the cell potential is also calculated as E cell is equal to E naught cell minus 2.303 RT by 1 if only one electron is involved in the reaction, then log concentration of Cl minus. Okay, the cell potential can be calculated from the next equation where E cell is equal to E naught cell minus 2.303 RT by 2. 2 is the, if number of electrons are 2, then it is a 2 log concentration of Cl minus ion to the power of 2. Okay, if 2 Cl minus ions are reduced, then the number of electrons are 2 and the power is 2. If only one Cl minus ion is involved in the reduction, then the number of electron is 1 and log concentration of Cl minus ion. Okay, these are the half-cell reactions in calomel electrode. This calomel electrode is also used as a secondary reference electrode. By using this electrode, the cell potential or the electrode potential of another half cell can be calculated. And here the cell potential is completely depends upon the concentration of KCl solution, where if one normal KCl solution is taken, then the electrode potential will become 0.33 volts. If the concentration of KCl is 1 normal, then the cell potential, the standard electrode potential, the standard reduction potential is 0.280 volts. For example, if the saturated amount of KCl is taken in the solution, then the standard reduction potential will become 0.2422 volts, and all these calculations are made at a particular temperature, that is 25 degrees centigrade. From these values, it is revealed that the cell potential is inversely proportional to the concentration of KCl solution. Here, lesser the concentration of KCl solution, more will be the standard reduction potential. And this is about the calomel electrode of metal insoluble salt ion electrode. Next, let us discuss about the second example of metal insoluble salt ion electrode. The example is silver chloride electrode. Here also the two solutions are there. One is a sparingly soluble solution and another one is a soluble salt solution. The silver chloride solution is a sparingly soluble salt solution and KCl is a soluble salt solution. This is a construction of silver chloride of cell. Okay, where the silver wire is coated with the silver chloride paste, and the silver wire is dipped in a glass tube where the KCl solution is present, and the silver wire is used for the electrical contact. This is a simple construction of silver chloride half cell. Again, it is connected with another half cell via salt bridge. Okay, a glass tube filled with the KCl solution, and it is dipped with a silver wire coated with silver chloride paste. The silver chloride salt solution is a sparingly soluble salt solution. KCl is a soluble salt solution. Let's discuss what type of cell reactions are occurred in silver chloride electrode. The half cell reactions are half-cell reactions. If this silver chloride electrode is acting as a cathode, if it is acting as a cathode, the reduction reaction is taking place. Reduction reaction is taking place where here the silver chloride gains one electron and converted into silver plus Cl minus. Silver chloride is a combination of Ag plus and Cl minus ion. Particularly, this Ag plus gain one electron and converted into as a silver metal, and this silver metal is deposited on the silver wire. The cell representation of this electrode is here the silver AgCl by Cl minus. Okay, for example, if it is acting as a anode where the oxidation reaction is taking place. If it is acting as a cathode, the reduction reaction is taking place, gaining of electron. The same electrode is acting as an anode, the oxidation reaction is taking place. The oxidation in terms of electron is the loss of electron is the oxidation. So here the silver lost one electron and converted into Ag plus ion. This Ag plus ion combined with the freely moving Cl minus ion and converted into AgCl, or the Cl minus ion of KCl solution converted into AgCl. Okay, these are the off-cell reactions of silver chloride electrode, and the cell potential of this off-cell is calculated from Nernst equation, and that is the E cell is equal to E naught cell minus 2.303 RT by NF. N is the number of electrons, only 1, and F log concentration of Cl minus ion. Concentration of product by concentration of reactants, but only we can consider the ions. Concentration is related to the only aqueous solution where the metal concentration change is equal to 1. That's why only Cl minus by AgCl. AgCl concentration is 1. That's why only log Cl minus ions are here. The E cell is equal to NF. N is equal to 1. Then E naught cell minus 2.303 RT by F log concentration of Cl minus ion. Okay, this is about the silver chloride electrode of metal insoluble salt ion electrodes.